Assalamualaikum and hi everyone. So let's discuss tutorial 6.2 number 14. Okay, you are given equation CO2 plus H2 produce CO plus H2O. So the equilibrium concentration of the reactant species are all equilibrium concentrations are given. Okay, calculate Kc for the reaction at 686 degrees Celsius. So just calculate the Kc. Okay, write the Kc expression, concentration of the products of a reactant. So the reactants are CO2 and H2. Okay, the concentration at equilibrium. Okay, already given, so just substitute the concentration equilibrium for each species. Okay, so we get the Kc 0.517. Okay, this is the Kc value for the reaction, okay, at this temperature. So for B, if we add a CO2 to increase its concentration to 0.5 molar. That means we add CO2 until the concentration of CO2 achieve 0.5 molar. So this is the new concentration of CO2. Okay, what will be the concentrations of all gases? B when the equilibrium is re-established. Okay, so just now we have the reaction that is in equilibrium, okay, because the question give you the concentration at equilibrium. But when we add some of the reactant or product, the equilibrium system will disturb. Okay, so in this case when we add CO2, okay, we add the carbon dioxide or the reactant. When we add CO2, the equilibrium system will be disturbed, so the system is not in equilibrium anymore. So what will happen? The reaction will adjust and try to achieve the equilibrium back. Okay, that's why the question asks you about the concentration of all gases when the equilibrium is re-established. Okay, when the equilibrium is achieved back. Okay, so how to relate the concentration given? Okay, just now the concentration given is concentration equilibrium, but when we add CO2 and the concentration of CO2 is increased, the equilibrium, the reaction is not in equilibrium. So we can use the new concentration of CO2 as the concentration initial. So we need to draw an ice table. Okay, so these are the concentration of all species given at equilibrium. Okay, we have 0.086 molar of CO2, 0.045 molar of H2, and 0.05 molar of CO, and 0.04 molar of H2O. Okay, so this is the concentration at equilibrium. But once we add CO2, okay, we add CO2 become 0.5. Okay, it is increased to 0.5 molar. Okay, so we change the concentration to 0.5 molar. So this is the new concentration of CO2. So once we add CO2, the equilibrium system is disturbed and the reaction is try to achieve the equilibrium back. Okay, so now all these concentration become concentration initial. because the system is not in equilibrium anymore. Okay, so the concentration change is since we add CO2, so the reactant is increased. Okay, we have more reactants compared to the product, so the system will shift forward from left to right, so the reactant will decrease in concentration and the product will increase in concentration. Okay, that's why we get minus X for the reactants and plus X for the products. Okay, so concentration at equilibrium will be 0.5 minus X for CO2, 0.045 minus X for H2, 0.05 plus X for CO, and 0.04 plus X for H2O. Okay, and then write the Kc expression. Okay, since Kc is given, the value of Kc is given in the questions, 0.517. Okay, we substitute the concentration for all species, okay, with unknown X. Okay, we don't have the value of X, so from this formula we can calculate the value of X. Okay, in this case you need to solve X using quadratic equation. Okay, so we will get X1 equals 0.025 and X2 negative 0.795. Okay, we have one negative value and one positive value, so we choose the positive value. Okay, choose the positive value and just ignore the negative value. So we take 0.025 molar for the value of X, and we can calculate the concentration of all gases at equilibrium. Okay, so concentration for CO2 is 0.5 minus 0.02 molar, which is equal to 0.475 molar. Okay, concentration for H2 is 0.045 minus 0.025. Okay, we will get 0.02 molar. Concentration of CO, carbon monoxide, is 0.05 plus 0.025 equals 0.075 molar. And last one, concentration of H2O, 0.04 plus 0.025 equals 0.065 molar. Okay, so we get the concentration at equilibrium for all gases in this reaction. Okay, that's all for question number 14. Thank you.